Hello students, now I'm going to do some problems related to thermodynamics. So here is the first problem. Calculate the difference between heats of reaction at constant pressure and at constant volume for the reaction at 25 degrees centigrade in kilojoules. So this is the equation given: 2C6H6 liquid state plus 15 O2 gaseous state gives rise to 12 CO2 gaseous state plus 6 H2O liquid state. So this is the sum. We have to calculate the difference between the heats of reaction. So what is heat of reaction? So heat of reaction is nothing but enthalpy change per mole between the product and the reactant of a reaction. Heat of a reaction is nothing but enthalpy change per mole. Enthalpy change per mole between the product and the reactant of a reaction. Product and reactant of a reaction. So that is nothing but the heat of a reaction means the difference between enthalpy change and internal energy. We know that the enthalpy change means the enthalpy is denoted by H. The change in enthalpy is denoted by delta H. So we know the equation delta H is equal to delta E plus delta N RT. Here we know that the delta H is nothing but change in enthalpy, that is equal to internal energy, change in internal energy plus delta N RT. What is delta N here? Here it is, the N is nothing but number of moles. Delta N is nothing but the change in the number of moles of gaseous products minus the number of moles of gaseous reactants in a chemical reaction. So this is the delta N, which was about gaseous substances. Okay, next, how can you calculate delta N value? So as I have told you that delta N is nothing but change in the number of moles of gaseous products. So what are the moles present in the gaseous state? In the product side, 12 minus the number of moles of gaseous reactants. So in the reactant side, the gaseous form, the gaseous molecules involved is 15. 12 minus 15 is nothing but minus 3. As we know that the R is nothing but universal gas constant. The value is 8.314 into 10 power minus 3 kilojoule per mole Kelvin. T is nothing but temperature, that was given 25 degrees centigrade. 25 degrees centigrade, that is to convert into Kelvin by adding 273. That is nothing but 298 Kelvin. So substitute these all values in delta H is equal to delta E plus delta N RT. In this equation, what we have to calculate is heats of reaction. Heats of a reaction is nothing but the difference between enthalpy and internal energy. Okay, for that purpose, delta H minus delta E, take this delta E towards left side, that is equal to delta N RT. So that is equal to, what is the value of delta N? Minus 3 into R value is 8.314 into 10 power minus 3 and T value is 298 Kelvin. So by solving this all, we'll get the answer minus 7.4 kilojoules. So what is the value? Minus 7.4 kilojoules. That is nothing but delta H minus delta E. What is this difference called as? Heats of a reaction. Delta H minus delta E, what they have given to solve. Okay, thank you.